You ever look up and just, I don't know, kind of envy birds?
You mean like wishing you could just take off and fly?
Exactly. That effortless soaring, all the impossible moves they pull off. It's like they've got the secrets of the sky, you know.
I get it. Humans have been trying to crack those secrets for, well, forever, haven't we?
We've gotten pretty good at it. But today, we're going deeper. We're looking at how birds, specifically how they fly, have actually shaped the design of, well, some of our most incredible tech fighter jets.
That's right. It's more than just being inspired by birds. It's about understanding their flight, their biology, and using that to design and build things like, well, those incredible
It's
jets.
like stealing secrets from nature's best pilots. So let's start with, I guess, the most obvious thing. Wings. Bird wings. They're practically the ultimate flying machines, right?
They really are, and they come in so many different shapes and sizes, each perfectly designed for a specific type of flight. Think about an albatross with those super long, slender wings.
Built for gliding forever, right?
Yeah.
Barely even flapping.
Exactly, perfect for long distances. Then you've got something like a hawk, short, broad wings, built for speed, for agility. It needs that for hunting.
Yeah, makes sense. So are you saying these different wing shapes, they've actually been used in, like, aircraft design?
All the time, especially for high-performance jets.
Yeah.
Like those swept-back wings you see on fighter jets, that's
Mhm.
directly influenced by birds like eagles and albatrosses. It helps reduce drag, and, well, you need that maneuverability, especially in a fighter jet.
It's like minimizing resistance, right?
Yeah.
For a smoother, faster flight. So that's where that design comes from.
It is, and there's a classic example, too, the Supermarine Spitfire, that World War II fighter.
Legend.
Jerry.
Yeah, beautiful plane. Those elliptical wings.
Well, those weren't just for looks. That shape, directly inspired by birds, helped distribute lift more evenly, meaning less drag, better stall characteristics. It gave the Spitfire a real advantage in a dogfight.
Wow, so it's not just copying a shape, it's about understanding the science, the physics, behind how birds fly.
Exactly. And birds have, over millions of years, become absolute masters of the fundamentals of flight: lift, drag, and thrust. Things we've studied, we've learned from, to make our own aircraft better.
It's incredible how much we've learned from them. Speaking of learning, there's this thing, I saw it in a documentary once maybe, called dynamic soaring. It blew my mind.
Oh yeah, dynamic soaring. It's how some birds, they use wind gradients like near cliffs or waves to gain altitude without even flapping their wings. Super efficient, especially for long distances.
Now that's what I call energy efficiency. Because we could apply that to our planes too.
Actually, engineers are already looking into it. There's a lot we can learn from how birds harness natural forces.
There's another thing that always gets me. Vortex lifting. It sounds almost impossible.
You're talking about those mini tornadoes, those swirling pockets of air that birds create with their wings to generate lift.
Yeah, it's like they're bending the air to their will. So wait, have we actually managed to copy that?
In a way, yeah. Engineers have learned to manipulate airflow over wings to create those vortices, especially on certain fighter jets. It really boosts maneuverability, especially at low speeds.
So it's like giving jets that extra edge in a dogfight, that bird-like agility. It's amazing how studying nature can lead to these breakthroughs. And speaking of fighter jets, well, the early ones, you can really see that bird inspiration, right? The sleek designs, the swept wings. What about the modern jets?
Oh, they've evolved. Take the F-22 Raptor or the Eurofighter Typhoon. They're complex machines for sure, but that bird influence, it's still there.
I can't even imagine trying to fly one of those.
Well, one thing they have, which is really interesting, is vector thrust nozzles. These things let the pilot actually redirect the engine exhaust, giving them, well, incredible control. It's a lot like how birds use their tails and wings to maneuver, changing direction on a dime.
It's like they're almost dancing in the sky. So it seems like this whole connection between nature and technology, it's still evolving. What's next, I wonder?
We're still learning from birds. There's so much potential to make aircraft even better, more efficient, more sustainable, just by studying how they fly. Imagine if we could perfectly copy a bird's ability to change its wing shape while it's flying.
That'd be revolutionary.
It would, and who knows, maybe someday we'll get there. The possibilities are, well, pretty much endless.
It's like we've only scratched the surface. So I guess the big takeaway here is birds haven't just been, inspiring for aircraft design. They've been, like, essential to the evolution of flight,
Uh,
especially for fighter jets. Who knew we owed so much to our feathered friends?
They really are incredible creatures. Next time you see a bird soaring, take a second, really look at it. You're looking at the future of flight. What seems effortless to them It holds so many secrets that could lead to, I don't know, maybe even bigger breakthroughs for us.
Definitely something to think about. Thanks for joining us for this deep dive. And remember, when it comes to learning from nature, the sky is the limit.
Absolutely. The sky's the limit.